guys, we're looking at simplifying radicals, and this is the part 2. So if you are lost on where we are, starting with square root of x to the 5th power, just back up and watch the first video. Alright, so simplifying square root of x to the 5th. What is the highest factor of x to the 5th that is also a perfect square? So in the last video, we looked at variables as well, and we know that x to the 4th is a perfect square. And we know that properties of exponents, if we have x to the 4th, that's times x to the 1st power, same base, add exponents, so x to the 4th times x to the 1st equals x to the 5th. So we have x to the 4th. Don't really have a lot of room to write under these radical signs here, but I'm trying. And then x to the 4th is x squared squared. And so x squared comes out times x to the 1st underneath the radical sign. All right, the next one says square root of 50 times x squared y. So we know that 25 is a perfect square, but we also know that x squared is a perfect square. So we're going to have 25 x squared times 2y. So under here, 25x squared, if you can read this, times 2y. 25x squared is the same thing as 5 times x squared times 2y. And the square root of 5x squared brings out the 5x. And then 2y is not a perfect square, so it stays underneath the radical sign. All right, so again, knowing your perfect squares is a good thing. If you need to pause the video, go ahead. We're going to keep moving. All right, to simplify the square root of 42 times 9 squared, you are, again, looking for a perfect square. So, let's see. 42 is 6 times 7, but neither of those is a perfect square or can be written as a perfect square. So the number is not going to be a perfect square, but we can look at the variable, x to the 9th. So we're going to have x to the 8th. Any even exponent can be pulled out a square root. So we're going to say x to the 8th is our largest perfect square. So we're going to have x to the 8th times, we still have the 42, and we have one more x, so x to the 1st. All right, so x to the 8th, and then 42x, and then x to the 8th is the same thing as x to the 4th squared, and then 42x, and so I can bring out the x to the 4th, and the 42x stays under the radical. All right, again, we're pulling out our largest perfect square, number, variable, or combination of both. All right, the next thing we're going to look at is your perfect cubes. Okay, a cube is a 3rd power. All right, so a number is a perfect cube if it's raised to the 3rd power, or if you have something times itself 3 times. All right, so let's look at our perfect cubes. So we're going to say 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. We got 27. We've got 64. And 125. Okay, again, if you're good at multiplying, you're going to see 2 times 2 is 4, 4 times 2 is 8, 3 times 2 is 9, 9 times 3 is 27, 4 times 4 is 16, 16 times 4 is 64, 5 times 5 is 25, 25 times 5 is 125. All right, same thing with variables. If you have a variable multiplied by itself 3 times, it's a perfect cubed. So x cubed, x squared cubed is a perfect cube, but if you simplify that, 2 times 3 is 6, and then 3, 6, 9, x cubed, or x to the 9th power. So 3, 6, 9, these are considered perfect cubes when you're talking about a variable. All right, a variable is a perfect cube if the exponent is divisible by 3. So if it's divisible by 3, it's considered a perfect cube. All right, taking the cube root of a number is the same as the square root, except it has an exponent of 3, or it's got something multiplied by itself 3 times. So it's going to be very similar to what we looked at with square roots. All right, so for example, x cubed equals 8, and the cube root of 8 equals 2. So it comes right back to this. The symbol cube root tells you to find something but times itself 3 times. So you're going to take out the perfect cubes. All right, so the symbol cube root tells you to simplify your cube root or reduce it into perfect cubes. All right, simplify the following radical expressions. All right, the first ones are pretty simple because they look to be perfect cubes. So the cube root of 125, that's 5 cubed. Cube root of 5 cubed, remember, is just 5. Cube root of 27 is 3. Cube root of x cubed is x. Cube root of 64 is 4. And 3 goes into 12 4 times. So it's divisible by that number, makes it a perfect cube. All right, now again, we're going to look at ones that are not perfect cubes. If you need to pause this to get all your notes, go ahead and do so. We're going to keep moving. All right, so non-perfect cubes. So we've got a cube root of 54. All right, so we know our cubes, again, are 1, 8, 27, 64, and 125. Well, if I think about 54, 27 times 2 is 54. And again, it's just about having a good number sense, knowing your multiplication tables. You can also use a calculator if you need to figure out some of these. But your highest factor and perfect cube is a 27. So 54 is 27 times 2. All we did was rewrite 27 times 2 instead of 54. So we're going to have 27 times 2, or 27 is 3 cubed. And cube root of a number cubed is just that number. So the 3 comes out, and we're left with the cube root of 2. So if we simplify cube root of 54, we get 3 times the cube root of 2. Now, when you're doing square roots, the index is assumed to be a 2 if there's nothing here. You have to put the 3 for the index for a perfect cube, or it does not indicate that it is a perfect cube. So don't forget your index when you're doing these. All right, so what is the highest factor and perfect cube of the radicand? So we've got cube root of 24x to the 8th. Well, I know that 8 is a perfect cube, and I know 8 goes into 24, so I'm going to put 8. And I also know 3 doesn't go evenly into 8, but 3 does go into 6. So I know my largest perfect cube for my power is x to the 6th. So we're going to have 8x to the 6th. 8 times 3 is 24. X to the 6th and x squared, same base. X is my base. Add exponents gives me x to the 8th. So all I did was rewrite that. So this expression has to equal this. All we're doing is rewriting it. So 8x to the 6th times 3x squared, and then 8 is 2 cubed, and x to the 6th is x squared cubed, and then 3x squared. These blanks really should have been bigger, knowing that I was going to write this on my screen. But anyways, so the 2 comes out, the x squared comes out, and we're left with cube root of 3x squared underneath. All right, so that's some examples of how to solve perfect squares and perfect cubes when we are simplifying radicals. It's important to know, again, your perfect squares and perfect cubes. If you have any questions, please let me know.